Welcome to Permutations and Combinations. Before you can calculate the probability of a complex event, you must first know how many ways that event can actually happen. This unit gives you the mathematical tools to count systematically, so you never have to draw exhaustive tree diagrams or list possibilities by hand. We will move from simple straight-line arrangements to highly complex scenarios with strict real-world constraints. Mastering this combinatorial logic is absolutely essential for Paper 5, and it forms the foundation you will need for the binomial distribution later on. Your journey starts with the mathematical engine of all counting, the factorial function. Denoted by an exclamation mark, n factorial is the product of all positive integers down to 1. It answers the most basic question: how many ways can I arrange n distinct objects in a line? You will learn to evaluate these rapidly and, more importantly, how to simplify complex algebraic fractions involving factorials without relying on your calculator. Next, we branch into permutations. The golden rule for a permutation is that the order of selection matters. Think of passwords, lineups, or assigning specific job titles. Choosing person A, then person B, creates an entirely different arrangement to choosing B than A. You will learn the permutation formula to select and arrange items from a larger pool, and you will discover exactly how to adjust your math when some of the objects you are arranging are identical. Then we look at the exact opposite scenario: combinations. Here, the order of selection simply does not matter. If you are picking a committee, a sports team, or just a handful of items, the group is the same regardless of who was picked first. You will train yourself to spot this difference immediately upon reading an exam prompt and use the combination formula to calculate unordered selections, combining them with the addition and multiplication rules. Finally, you will face the A-star discriminator of this unit: arrangements with restrictions. Examiners will rarely ask for a simple arrangement. Instead, they will insist that certain items must be kept together or that specific items must be separated. You will master visual strategies for this. For example, when items must stay together, you will learn to fuse them into a single block, arrange the block among the other items, and then multiply by the internal arrangements of the block itself. This logical structuring is where the heavy marks are won. By the end of this unit, you will be able to evaluate and manipulate factorials, instantly distinguish between situations requiring permutations and combinations, and confidently dismantle complex restriction problems by breaking them into simpler cases. The foundation of probability awaits. Let us get started.